day 7, question 1. Show that number 1, cos 2x over cos x plus sin x is same as cos x sin x. Okay, I've given you the cos 2x identities, so we're going to use this, okay, at some point to solve this. Okay, let's do the first one. I think that's not difficult one. So what I'm going to do, I'm going to use the first one, cos 2x, as cos 2x equals to cos x square minus sin x square, okay, over, this is cos x plus sin x, okay, over cos x, okay, this is the same as plus sin x. Okay, this I can simplify to cos x plus sin x bracket sin cos x minus sin x, and the whole thing divided by cos x plus sin x. So this 2 gets cancelled, so that leaves you with cos x minus sin x. Okay, so it's proved what's on the left equals to same as what's on the right. Now for part 2, this is part 1. So for part 2, half cos 2x minus sin 2x is same as cos x square minus cos x sin x minus half. Okay, sometimes you gotta try few times before you get it, but since I've already did it a little bit of a while ago, okay, so I know which identity that I have to use, or otherwise, you know, you guys have to try one of each identities for you guys to get. But the more practice you do, you'll be able to get this. Okay, so what I'm going to do, I'm going to take a half cos 2x, I'm going to change it to 2 cos x square minus 1. Okay, 2 cos x square minus 1, and then minus sin 2x is bracket 2 sin x cos x. Okay, close bracket. Okay, that's on the left. Okay, now let's work here. So if I expand this, it's half, so you get 2 cos x square minus 1 minus 2 sin x cos x. Okay, sin x cos x. Now if I times this half inside, half times by 2 cos x will give me cos x square, and then half times by negative 1 is negative half, and then half times by negative 2 sin x cos x is negative sin x cos x. Okay, now let's rearrange this. So when I rearrange, you get cos x square minus sin x cos x minus half. Okay, so that is same as what's here. Okay, next question. Hence or otherwise, show that the equation cos theta bracket cos 2 theta over cos theta plus sin theta equals to half. Okay, so let's do this now. Okay, so we have cos theta bracket cos 2 theta over cos theta plus sin theta equals to half. Okay, and we have to show that it can be written as, on the left, sin 2 theta equals to cos 2 theta, or the other way around. Okay, so let's work this. So now if I use cos theta over, this is cos theta over sin theta. Okay, yeah, cos 2 theta, what do I get? Cos 2 theta is, that's given as, okay, cos 2 theta, can you guys see here? This is same as this one, yes. That's what I was looking for. Okay, so that is same as cos theta minus sine theta. So cos theta minus sine theta, okay, equals to half. So expand that, so you get cos theta square minus sine theta and cos theta, and this is equals to half, times that's 2, so 2 cos theta square minus 2 sine theta and cos theta, and that is equals to 1. So bring the 1 inside, cos theta minus 1 equals to 2 sine theta cos theta, which this is sine 2 theta, and this is cos 2 theta, or swap that around. Okay, you still get sine 2 theta equals to cos 2 theta. Okay, that's what the question wants. Okay, prove that. Okay, now this one we can change it to sine over cos. So sine 2 theta divide by cos 2 theta. Okay, that's the next part. Okay, part C, solve for theta between 0 to 2 pi. So this is part C. Sine 2 theta over cos 2 theta, that is equal to 1, which is tangent 2 theta equals to 1, and it's between 0 to 2 pi. So 0 less than theta less than 2 pi. Okay, less than 2 pi. Okay, now so 2 theta equals to shift tangent 1, which is pi over 4. So 2 theta equals to pi over 4. Next, okay, so this is first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so tangent first quadrant positive, and then the third quadrant 180 plus 45, which is 2 to 5, and 2 to 5 is 5 pi over 4. Next is it goes back to the first quadrant again, which is 9 pi over 4, and then it goes back to the third quadrant, which is 13 pi over 4. You can go back again, that will be more than 2 rounds. Okay, 720, and then plus 45, which is 765, but you don't have to do that. Okay, so just keep it up to 2 rounds. Okay, first round 360, second round 720, that's enough. Now theta equals to pi over 8, 5 pi over 8, and then 9 pi over 8, and 13 pi over 8. Okay, if you go one more round, which is more than 720, so that would be 17 pi over 4. Okay, and if you times this, divide this by 2, you get 17 pi over 8, and this is more than, if you use your calculator, 17 pi, 17 times by 180, 17 times by 180, and then divide this by 8, it gives me 382.5. so that's more than 2 pi. So discard this. Okay, so that's your answer. Okay, day 7, question 2. The function f and g are defined by fx equals to 2x plus ln 2, where x, the element of x are all real values. Likewise, gx, all the elements for x are real values. Gx is given e to the power of 2x. Prove that the composite function gf is gf equals to 4 e to the power of 4x. Okay, composite function. Okay, a. It's given as gfx. This is same as gfx equals to 4e4x. This is what we get a proof. Okay, so g f into x, and this is right. Let's write the g first. What is g? G is e to the power of 2x, so e to the power of 2, and then this is where fx goes in. Okay, so therefore e to the power of 2 bracket 2x plus ln 2, okay, which is e to the power 4x plus 2 ln 2, which is e to the power of 4x plus ln 4. Okay, so now when its index is plus, basically the base you gotta times. Okay, so I'm gonna split this times by e ln 4. Okay, so this is the same as e to the power of 4x, but ln 4, okay, exponential to the power of natural log of 4. Okay, so therefore it gives you just 4. Okay, so your answer is 4 e to the power of 4x. Okay, that's all. Okay, next for part B. For part B, in a space provided, okay, basically we're going to draw it here. You have to draw this curve. Okay, that's not difficult. Okay, so B equals to, this is an exponential curve. Okay, exponential curve. It goes almost closer to 0 but doesn't touch the 0. It just keeps going closer to 0. Okay, and then it goes up like that. And this point, excuse me, so this is y-axis and this is x-axis. And since this is y to the power, y equals to 4e to the power of x, when x equals to 0, when x equals to 0, e to the power of 0, which is 1, so this has to be 4. Okay, so that's your graph. Okay, y equals to 4x. Okay, next, write down the range. Okay, write down the range. What is the range? Okay, the closest that it can go is 0, but it won't touch the 0, so it starts from 0, and if you look at it, it goes all the way up from 0 all the way. Okay, if I extend this line, it just goes to infinity. So therefore your range for this is, okay, for C, range is g f x is greater than 0. Okay, and next for D, find the value of x for which the differentiation of g f x equals to 3. Okay, differentiation of gx equals to 3. So differentiate g f x over dx equals to 3. So we already got g f x, which is 4e to the power of 4x. Okay, so basically differentiate 4e to the power of 4x in terms of x, and this equals to 3. So when you differentiate, you can take out 4 and then basically differentiate d e to the power of 4x, okay, equals to 3. So you get 4 times by e to the power of 4x, differentiate 4x gives you 4 over, sorry, there's no over, okay, equals to 3. So therefore 16 e to the power of 4x equals to 3. Therefore e to the power of 4x equals to 3 over 16. Okay, now if I want to find 4x, 4x equals to ln, okay, 3 over 16. Okay, and the answer for that is 4x equals to negative, use calculator at this point. Okay, it is same as ln 3 minus ln 16, but you don't have to do that. Just use calculator, and calculator will give you the answer, which is negative 1.673976. That's what I got. Therefore x equals to negative 1.673976. Divide by 4, and the answer is x is approximately to 3 significant figure, negative 0.418, okay, to 3 SF, and that is the answer. Okay, day 7, question 3. Figure 1 shows a sketch of curve with equation y equals to fx, f is greater than 0, where f is an increasing function of x. The curve crosses the x-axis at the point 1, 0, and the line x equals to 0 is an asymptote to the curve. On a separate diagram, sketch the curve with the equation ay equals to f2x. Okay, what does f2x means, or y equals to f2x? It means that, okay, y equals to, it means, okay, we can write it as, let's say if you have fcx, okay, where c is greater than 1, then the graph what happens to the graph is there's a horizontal shrunk. Okay, horizontal shrunk happens to the point. Okay, what does that mean? Let's say if we have a coordinate x, y. Okay, x, y will become, the x coordinate will shrink to x over c. Okay, if I have x as 8, so since it's f2x, you have to take 8, divide by 2, so it becomes 4. So in this case, the coordinate here is 1, 0. Therefore, the new coordinate is half 0. So I can sketch that. Okay, it's the same thing. Okay, so instead of 1, this time we have half 0, and this is y equals to fx, and this is x-axis. Done. Okay, next, y equals to fx modulus fx. Okay, this is for b. Y equals to modulus fx. Okay, where x is greater than 0. This is a reflection. All the negative region which is below the x-axis gets reflected to reflection on x-axis. Okay, on x-axis. So basically all the positive values below, negative values below the x-axis will be reflected to above the x-axis. Okay, on x-axis. Okay, sorry. Okay, reflection on x-axis. So negative values, negative y values will be reflected to same positive y values. Okay, positive y values. Okay, that's what modulus means. So let's sketch this. So I'm going to use, okay, this is y, and then, okay, let's say I'll start off with a dotted line, dot goes up, and then I'll use the black color. So basically this line which is below the x-axis is the dotted line, so you have a reflection of that and that. So the cusp here is still 1, 0, and then this is y equals to fx. Okay, so that's your B.